Imagine stepping onto a train in London, falling asleep somewhere beneath the Arctic, and waking up in New York City. No airports, no ships, no ocean crossings. It sounds impossible. Because between Asia and North America lies one of the most hostile places on Earth, the Bering Strait. A frozen wilderness where temperatures plunge below -40 degrees, tectonic plates collide beneath the seabed, and violent Arctic storms can destroy entire structures. Yet today, engineers, economists, and world leaders are asking a question once considered madness. What if we connected the continents? What if humanity built a railway beneath the ocean, linking the entire world into a single land network? This isn't science fiction, this is the Iron Silk Road. And if it ever becomes reality, it could become the largest engineering project in human history. Imagine boarding a train in London, settling into your seat, and beginning a journey unlike anything humanity has ever attempted. Hours pass as cities, forests, and mountains race by your window. Europe fades behind you. Asia stretches endlessly ahead. Then, somewhere deep beneath the frozen Arctic, your train enters a tunnel unlike any ever built. When you emerge on the other side, you are no longer in Asia. You are in North America. For most people, that sounds like science fiction. But for more than a century, engineers, governments, and dreamers have been fascinated by a question that refuses to disappear. What if humanity connected the continents? At the very edge of northeastern Russia lies Cape Dezhnev. Across the icy waters sits Alaska's Cape Prince of Wales. Between them is the Bering Strait, a harsh stretch of ocean that separates Asia from North America. Despite dividing two massive continents, the distance is surprisingly small. At its narrowest point, the gap is only about 82 kilometers. 82 kilometers. That is shorter than many daily commutes in major cities. Yet this narrow strip of water represents one of the greatest barriers on Earth. For thousands of years, the Bering Strait has stood as a natural boundary between worlds. Ancient humans once crossed this region during the Ice Age, walking across a land bridge that no longer exists. Those travelers became the ancestors of millions across the Americas. Long before ships, airplanes, or satellites existed, this frozen frontier shaped the course of human history. Today, however, humanity faces a different challenge. Our world is more connected than ever before. Goods travel between continents every second. Trillions of dollars move through global trade networks. Entire economies depend on transportation routes stretching across oceans and borders. Yet one enormous gap remains, the final missing link. The last place where the world's largest landmasses almost touch but remain separated, and that is where the Iron Silk Road begins. This is not merely a railway project. It is a vision that could reshape global transportation forever. Supporters. Imagine high-speed trains carrying passengers from Europe to North America without crossing an ocean by ship or airplane. Freight trains loaded with goods could move between continents through a direct land connection. Entire regions of the Arctic could become gateways to a new era of global trade. But before any of that can happen, humanity must confront one brutal reality. The Bering Strait is one of the most hostile environments on Earth. Winter temperatures can plunge below -40 degrees Celsius. Massive ice sheets drift through the water. Violent storms batter the region year-round. Beneath the surface, powerful geological forces constantly reshape the seabed. Everything about this place seems designed to stop human ambition. And yet, every generation produces people willing to challenge the impossible. Standing on the rocky coastline of eastern Russia, looking across the freezing waters toward Alaska, it is easy to understand why this dream continues to captivate engineers. The continents appear almost close enough to touch. On clear days, islands rise from the sea between them, like stepping stones connecting to worlds, so close, yet so far. For more than 100 years, visionaries have asked the same question. Could humanity build a permanent bridge between continents? Could we create a transportation corridor that finally unites the eastern and western hemispheres? And if we can, what for the future? The answers may lie beneath the ice, hidden in one of the most ambitious engineering concepts ever imagined. Because the story of the Iron Silk Road is not just about trains. It is about humanity's endless desire to connect, explore, and overcome the barriers that separate us. And this is only the beginning. The idea of connecting Asia and North America sounds like something invented by modern engineers. Massive tunnels, high-speed trains, and global transportation networks feel like products of the 21st century. But surprisingly, the dream is much older. More than 100 years ago, long before commercial aviation existed, long before satellites orbited Earth, and long before the internet connected billions of people, visionaries were already imagining a railway that could unite the continents. In 1905, an extraordinary proposal emerged from the Russian Empire. At the time, Russia controlled vast territories stretching across Eurasia. The Trans-Siberian Railway was transforming transportation across the continent, linking distant cities through thousands of kilometers of steel track. To many engineers, it represented proof that seemingly impossible distances could be conquered. But some dreamers wanted to go even further. Far beyond the forests of Siberia, beyond the mountains and frozen tundra, they looked toward the Bering Strait. Instead of seeing an ocean barrier, they saw an opportunity. Imagine the reaction. Most people considered the idea absurd. The region was remote, hostile, and almost completely undeveloped. Even reaching the area was an enormous challenge. Building a railway there seemed impossible. Yet the vision persisted. Supporters imagined a future where trains could travel continuously from Europe into Asia and eventually reach North America. They believed such a connection would transform global commerce, encourage cultural exchange, and create unprecedented economic opportunities. The proposal never became reality. The technology of the era simply wasn't capable of overcoming the immense engineering obstacles, political instability, economic limitations, and global conflicts soon pushed the dream into the background. Then came World War I. Then the Russian Revolution, then World War II. For decades, humanity became consumed by survival, conflict, and reconstruction. Throughout the 20th century, the idea repeatedly resurfaced. Engineers, economists, and futurists continued to study the possibility. Every time technology advanced, someone would ask the question again: could it finally be possible? As tunnel construction improved, the concept gained new attention. When engineers successfully built massive underwater tunnels in other parts of the world, the Bering Strait suddenly seemed slightly less impossible. The Channel Tunnel connected Britain and France beneath the English Channel. Japan built the second tunnel beneath the sea. Norway continued pushing the boundaries of underwater engineering. Each achievement demonstrated humanity's growing ability to conquer environments once thought untouchable. The impossible was slowly becoming possible. At the same time, globalization was transforming the world economy. Factories, ports, and supply chains became interconnected on a scale never seen before. Nations increasingly depended on trade routes stretching across continents and oceans. The world was becoming smaller, and the value of connecting distant regions was becoming larger. Suddenly, the century-old dream no longer looked like fantasy. It looked like a future opportunity. Today, modern proposals envision a system far more ambitious than the original plans. Instead of a simple railway crossing, engineers imagine a vast transportation corridor linking Europe, Asia, and North America into a single network. Supporters argue that such a project could redefine international trade. Critics warn that the costs and risks would be enormous. Both sides agree on one thing: if built, it would become one of the greatest engineering achievements in human history. Yet, before humanity can connect the continents, it must first solve a problem that has challenged every generation of dreamers. How do you build infrastructure in one of the harshest environments on Earth? How do you construct a transportation link where freezing temperatures, shifting ice, violent storms, and geological forces constantly threaten everything humans create? That challenge begins beneath the ice, and it is far more difficult than most people realize. Engineering beneath the ice. If the dream of connecting continents sounds difficult, the reality is even more intimidating. The Bering Strait is not simply a stretch of water separating Russia and Alaska. It is one of the most unforgiving environments on Earth, a place where nature seems determined to resist every human attempt to tame it. For much of the year, the region is locked in ice. Winter temperatures can plunge below -40 degrees Celsius. Powerful Arctic winds sweep across the frozen landscape with incredible force. Massive ice sheets drift through the strait, crushing anything unfortunate enough to stand in their path. This is not an environment where construction crews can simply arrive and start building. Every step would be a battle against nature itself. At first glance, building a bridge might seem like the simplest solution. After all, the distance between the continents is only about 82 kilometers. But engineers quickly discovered a problem, actually, several problems. The Bering Strait is located in a region where enormous ice masses move constantly. During risk and powerful, any bridge spanning the strait would need to survive relentless impacts from moving ice year after year. Then there are the storms. Arctic storms can generate dangerous waves, extreme winds, and conditions that make construction operations nearly impossible. Maintaining a bridge in such an environment would require extraordinary resources and constant repairs, and beneath it all lies another threat: the Earth itself. The Bering Strait sits near active tectonic zones where geological forces are constantly reshaping the region. While major earthquakes are uncommon compared to some parts of the Pacific Ring of Fire, engineers must still design any structure to withstand seismic activity. Suddenly, the challenge becomes much larger than simply connecting to coastlines. That is why many modern proposals focus on tunnels instead of bridges. A tunnel deep beneath the seabed could avoid many of the dangers found on the surface. Protected from storms, drifting ice, and extreme Arctic weather, it could provide a safer and more reliable transportation route. But tunneling beneath the Bering Strait creates a completely new set of challenges. Engineers would need to excavate through frozen ground, unstable rock formations, and remote terrain far from major industrial centers. Every machine, every worker, and every piece of equipment would need to be transported into one of the most isolated regions on Earth. Even supplying construction crews could become a logistical nightmare. Imagine building one of the world's largest tunnels where there are almost no roads, almost no cities, and almost no existing infrastructure. Everything would have to be created from scratch. Entire support facilities, power stations, worker housing, maintenance centers, transportation hubs. Before the tunnel could even begin, a massive network of supporting infrastructure would need to be built across thousands of kilometers of Arctic wilderness. And yet, despite all these obstacles, engineers remain fascinated by the project. Because history has repeatedly shown that humanity often succeeds when confronted with seemingly impossible challenges. The Panama Canal was once considered impossible. The Channel Tunnel was considered impossible. Landing humans on the moon was considered impossible. Every generation inherits a list of dreams that experts claim cannot be achieved. Then someone proves them wrong. The Iron Silk Road may ultimately join that list. But before humanity can link continents beneath the Arctic Ocean, one question remains unanswered. How exactly would such a tunnel be built? And what would it look like beneath the frozen waters of the Bering Strait? The answer may be the most ambitious engineering design ever proposed. The tunnel that could change the world. If engineers decide to connect Asia and North America, the solution will likely not rise above the ocean. It will disappear beneath it, far below the freezing waters of the Bering Strait. Hidden beneath layers of rock and seabed, a gigantic transportation tunnel could one day become humanity's newest gateway between continents. The concept is breathtaking. If engineers decide to connect Asia and North America, the solution will likely not rise above the ocean. It will disappear beneath it, far below the freezing waters of the Bering Strait, hidden beneath layers of rock and seabed. A gigantic transportation tunnel could one day become humanity's newest gateway between continents. The concept is breathtaking. Modern proposals suggest a tunnel system stretching more than 100 kilometers, making it one of the longest underwater transportation tunnels ever constructed. Deep beneath the Arctic Ocean, high-speed trains could travel through specially designed passages protected from storms, ice, and the violent weather above. Passengers might never even realize they are crossing between continents. But creating such a tunnel would require some of the most advanced engineering technology on Earth. The process would begin with tunnel boring machines, often called TBMs. These incredible machines are essentially underground factories. Some are longer than a football field and weigh thousands of tons. Their enormous, rotating cutter heads grind through rock while sophisticated systems reinforce the tunnel walls behind them. Slowly, relentlessly, meter by meter, day after day, month after month, year after year. Deep beneath the Arctic seabed, multiple TBMs could work simultaneously from different directions. Some would begin in Russia. Others might start from Alaska. Their ultimate goal would be a precise underground meeting point beneath the Bering Strait itself. The level of accuracy required would be astonishing. After drilling for years through darkness and solid rock, the tunnels would need to meet with almost perfect precision. Even tiny errors could create massive problems. Yet modern engineering has already achieved similar feats elsewhere. The Channel Tunnel beneath the English Channel successfully connected Britain and France through one of the greatest tunneling projects in history. Engineers working from opposite sides met with extraordinary accuracy deep underground. The Bering Strait project would take that achievement to an entirely new level. Inside the tunnel, advanced systems would constantly monitor safety conditions. Powerful ventilation equipment would circulate fresh air. Emergency escape passages would run alongside the main tunnels. Sophisticated sensors would track temperature, pressure, structural movement, and potential hazards 24 hours a day. The tunnel would become a living machine, a vast underground ecosystem designed to transport millions of passengers and enormous quantities of cargo safely beneath the Arctic Ocean. Some proposals even include service tunnels, maintenance corridors, communication networks, power infrastructure, and emergency shelters hidden deep within the system. It would not simply be a tunnel. It would be an underground city of engineering. Yet perhaps the most remarkable aspect of the project is what passengers might experience. Imagine boarding a train in Berlin. Hours later, you cross through Russia's vast wilderness. Then comes the Arctic. The train enters a tunnel beneath one of the most remote places on Earth. Above your head lies the freezing Bering Strait. Massive ice sheets drift across the ocean surface. Arctic storms rage in darkness. But inside the tunnel, the journey continues smoothly. A few hours later, you emerge into Alaska without boarding a ship, without stepping onto an airplane, without realizing that you have just crossed from one continent to another. For the first time in history, Eurasia and North America would be connected by a continuous land transportation network. A dream that once seemed impossible would become reality. But building the tunnel is only part of the challenge. Because once the continents are connected, the world itself could begin to change in ways few people expect. And that transformation could affect billions of lives. The human story behind the megaproject. When people hear about the Iron Silk Road, they often focus on the engineering. The tunnels, the trains, the billions of dollars, the technology. But the true story is not about steel, concrete, or machines. It is about people. Because every great transportation revolution in history has ultimately changed human lives. Imagine a father working thousands of kilometers away from his family. Today, crossing continents often requires multiple flights, expensive tickets, long security lines, and exhausting travel schedules. Now, imagine a future where international rail networks connect entire continents. A journey that once required complicated travel arrangements becomes simpler, faster, and more accessible. For millions of families, distance could feel smaller than ever before. Then consider global trade. Right now, countless products travel across oceans aboard massive cargo ships. These routes are effective, but they can also be vulnerable to delays, storms, political tensions, and disruptions. A direct land connection between continents could create new transportation options for businesses around the world. Factories could receive materials faster. Products could reach markets more efficiently. Entire regions that were once isolated could become important economic centers. But perhaps the greatest impact would be felt in places that few people currently notice: the Arctic. For centuries, much of the Arctic has remained one of the least populated regions on Earth. Vast stretches of wilderness extend across northern Russia and Alaska. Small communities survive in some of the harshest environments imaginable. A project of this scale could bring new infrastructure, jobs, investment, and opportunities to areas that have long existed on the edge of global development. Supporters believe the project could create tens of thousands of jobs during construction alone: engineers, construction workers, technicians, scientists, logistics specialists. Entire generations could participate in building one of the largest infrastructure projects in human history, yet the benefits are not only economic, they are cultural. Throughout history, transportation networks have connected people who would otherwise remain strangers. The Silk Road linked civilizations across Asia, Europe, and the Middle East. Railroads transformed nations. Air travel connected continents. Every major transportation breakthrough brought cultures closer together. The Iron Silk Road could continue that tradition on an unprecedented scale. A student in Europe could travel across Eurasia and into North America by rail. Researchers could collaborate more easily across continents. Tourists could experience journeys that were once unimaginable. The world might begin to feel smaller, not because distances have changed, but because humanity has found new ways to overcome them. Of course, not everyone agrees that the project is worth pursuing. Critics argue that the costs would be enormous and the challenges overwhelming. Some believe the money could be better spent elsewhere. Others question whether enough passengers and cargo would use the route to justify the investment. These are important questions, and they deserve serious consideration. But history offers an interesting lesson. When the first transcontinental railroads were proposed, many people called them unrealistic. When massive bridges and tunnels were first imagined, critics dismissed them as impossible. Yet today, many of those projects are considered essential parts of modern civilization. The future often begins as an idea that seems too ambitious to succeed. And sometimes, the biggest projects are not built because they are easy. They are built because they inspire people to imagine a different future, a future where continents are connected, where distance matters less, and where humanity continues doing what it has always done best, reaching beyond the horizon. Could you really travel from London to New York for a moment? Forget the engineering challenges, forget the political debates, forget the enormous cost. Instead, imagine that the Iron Silk Road already exists. The year is 2055. You arrive at London's International Rail Terminal carrying a small suitcase. There are no crowded airport security lines, no boarding gates, no long waits on a runway. You simply board a train, the doors close. The journey begins. As the train accelerates across Europe, cities blur into the distance. England gives way to continental Europe. Fields, rivers, mountains, and forests race past your window. Hours later, you enter Eastern Europe and continue toward the vast landscapes of Asia. The train never stops for an ocean, because there is no ocean crossing. Only rails. Days pass comfortably inside a high-speed transportation network that spans thousands of kilometers. Passengers sleep, work, eat, and watch the world unfold outside. Then the landscape begins to change. The forests become thinner. The towns become rarer. Snow-covered wilderness stretches to the horizon. You have entered the Arctic frontier. Outside, temperatures plunge far below freezing. Violent winds sweep across endless tundra. The environment becomes increasingly hostile, yet the train continues forward. Ahead lies one of the most remarkable sections of the entire journey: the Bering Strait tunnel. Slowly, the train enters a vast underground passage carved deep beneath the ocean floor. Above your head lies one of the most remote and dangerous regions on Earth. Thousands of tons of seawater, moving ice sheets, Arctic storms, freezing darkness. But inside the tunnel, everything remains calm, quiet, safe. For nearly an hour, passengers travel beneath the ocean itself, without seeing it, without feeling it, without realizing they are crossing one of the greatest geographical boundaries on Earth. Then something extraordinary happens. The train emerges from the tunnel, and suddenly, you are no longer in Asia. You are in North America. No airplane, no ship, no passport control at an airport terminal. Just a continuous railway journey connecting to continents. For the first time in human history, it would be possible to travel between Eurasia and North America entirely by land. The implications are staggering. Tourism could be transformed. International trade could gain new transportation options. Entire regions could become connected in ways previously unimaginable. Some futurists even envision a global rail network stretching from Western Europe through Asia and into North America. A traveler could theoretically begin a journey in Portugal and eventually reach Canada or the United States using nothing but rail connections. It sounds like science fiction, yet many things that define modern life once sounded impossible. Crossing oceans in hours, communicating instantly across continents, walking on the moon. Every era has its impossible dream. The question is whether the Iron Silk Road will become the next one. Because while the vision is inspiring, there is one major obstacle standing in the way: money. And building the world's most ambitious railway connection may require an investment unlike anything humanity has ever attempted. That challenge could determine whether this dream remains on paper or becomes reality. The price of connecting the world. Every great dream comes with a price. And the dream of connecting Asia and North America may carry one of the largest price tags in human history. For decades, engineers, economists, and governments have debated the same question, not whether it is possible, but whether humanity is willing to pay for it. Modern estimates suggest that a complete Iron Silk Road network, including tunnels, railways, power systems, maintenance facilities, and supporting infrastructure, could cost well over $100 billion. Some projections are even higher: 200 billion, 300 billion, perhaps more. The final number would depend on technology, political cooperation, labor costs, environmental protections, and countless other factors. The scale is almost impossible to imagine. To put it into perspective, that amount of money could fund thousands of hospitals, schools, airports, and infrastructure projects around the world. Critics argue that such resources should be spent solving more immediate problems. Supporters see things differently. They point to history. When the Panama Canal was proposed, many believed it was too expensive. When the Channel Tunnel connected Britain and France, critics called it financially risky. When humanity decided to send astronauts to the moon, countless people questioned the cost. Yet today, those projects are remembered as milestones of civilization. Their impact extended far beyond the money spent to build them. The Iron Silk Road could represent a similar moment. A project so ambitious that future generations might view it as a turning point in global transportation. Supporters believe the economic benefits could eventually outweigh the initial investment. Faster trade routes, new business opportunities, regional development, tourism growth, employment creation, expanded transportation networks. Entire industries could emerge around the new corridor. Some economists compare the idea to building a new digital internet, except instead of data moving across continents, physical goods and people would move through a giant transportation network connecting the world's largest landmasses. But funding such a project would require something even more difficult than engineering: cooperation. No single country could easily build the Iron Silk Road alone. The route would involve multiple nations, multiple governments, and multiple economic systems. Countries would need to work together for years, possibly decades. Agreements would need to be negotiated. Regulations would need to be aligned. Security concerns would need to be addressed. Political tensions would need to be overcome. In many ways, the financial challenge is actually a human challenge. Can nations cooperate on a project larger than any single country? Can leaders think beyond election cycles and short-term interests? Can humanity invest in something that may take decades to complete? These questions have no simple answers. Yet history shows that some of the world's greatest achievements happen when people decide to pursue goals larger than themselves. Goals that seem impossible at first. Goals that unite generations. Goals that leave a legacy long after the builders are gone. Perhaps that is why the Iron Silk Road continues to capture imaginations around the world. Because beneath the numbers and engineering diagrams lies something deeper, a vision. A belief that humanity can still accomplish extraordinary things when it dares to dream on a global scale. But even if the money is found, even if the tunnel is built, even if the railway connects the continents, one final challenge remains. The challenge that could determine whether the project succeeds or fails. Politics. And as history has shown many times before, political obstacles can be even harder to overcome than mountains, oceans, or ice. The political battle for the Iron Silk Road. Engineering may build the tunnel, money may fund the project. But politics could decide its fate. Because the Iron Silk Road is not simply a railway. It is a connection between some of the world's most powerful nations, and that makes everything more complicated. At first glance, the project seems straightforward. Russia sits on one side of the Bering Strait. The United States sits on the other. Between them lies one of the shortest distances separating two continents. But geography is only part of the story. History is the other. For more than a century, relations between major world powers have shifted constantly. Alliances have formed and collapsed. Governments have changed. Economic interests have evolved. Global priorities have moved in different directions. A project lasting decades would need to survive all of those changes. Imagine the scale of cooperation required. Engineers from different countries working together. Shared safety standards. Shared transportation regulations. Shared security systems. Shared economic agreements. Every major decision would require international coordination. And that is where the challenge begins. Supporters argue that the Iron Silk Road could become a symbol of cooperation. A project that encouraged nations to work together rather than compete. Throughout history, major trade routes have often reduced isolation and increased economic interdependence. Countries connected through commerce are frequently motivated to maintain stability. The ancient Silk Road helped link civilizations across continents. The modern Iron Silk Road could potentially do the same. But critics remain cautious. They point out that transportation corridors can also create strategic concerns. Questions immediately arise. Who controls the route? Who secures the tunnel? Who manages customs and immigration systems? Who responds during emergencies? What happens if diplomatic relations change? These questions are not theoretical, they are essential. Any transportation link connecting continents would become a critical piece of global infrastructure. Governments would need guarantees regarding security, reliability, and long-term access. Then there is the Arctic itself. The Arctic is becoming increasingly important in global geopolitics. As climate conditions change, new shipping routes are emerging. Natural resources are growing. Attention! Nations are expanding research stations, infrastructure projects, and strategic interests throughout the region. The Bering Strait sits directly within this evolving landscape. That means the Iron Silk Road would not simply be a transportation project. It would become part of a much larger geopolitical story. Some analysts believe the project could strengthen economic cooperation across the Northern Hemisphere. Others worry it could become vulnerable to future political tensions. The truth is that nobody knows for certain. Because projects of this scale are rare, humanity has never attempted anything quite like this before. And yet, despite all the challenges, the idea refuses to disappear. Every few years, new studies appear, new proposals emerge, new discussions begin. The dream survives. Perhaps because deep down, people understand something important. Technology can solve many problems. Engineering can overcome extraordinary obstacles. Money can fund ambitious projects. But the future ultimately depends on whether people choose to work together. The Iron Silk Road is not only a test of engineering. It is a test of cooperation, a test of vision, a test of whether humanity can build something larger than national borders. And if that challenge can be overcome, the reward could be extraordinary. Because the impact of connecting continents may extend far beyond transportation. It could fundamentally reshape the future of global civilization. What could go wrong? Every great project in history faces a moment when optimism collides with reality. And for the Iron Silk Road, that reality is brutal. Because connecting continents beneath one of the harshest environments on Earth is not just difficult, it is dangerous, very dangerous. The first threat comes from the Arctic itself. Unlike most construction projects, the Bering Strait exists in a constantly changing environment. Ice shifts, temperatures fluctuate, powerful storms sweep across the region. Conditions that seem stable today may be completely different tomorrow. Engineers can design for known risks, but nature often creates unknown ones. Then there is the problem beneath the surface. The tunnel would pass through complex geological formations hidden beneath the seabed. Some areas contain unstable rock, unexpected terrains, or frozen ground. Conditions that could complicate excavation. A single unexpected discovery could delay construction for months or even years. History has shown this before. Many of the world's largest tunnels encountered surprises, deep underground conditions that no survey could fully predict. And every surprise costs time. Every surprise costs money. But perhaps the greatest environmental concern is climate change. The Arctic is warming faster than many other regions of the planet. Permafrost that has remained frozen for thousands of years is beginning to thaw in some areas. For engineers, this creates a serious challenge. Infrastructure built on permanently frozen ground depends on that ground remaining frozen. If temperatures continue changing, roads, railways, foundations, and support structures may require constant adaptation. The very landscape itself could evolve during the lifetime of the project. Then comes another challenge: security. Imagine a transportation corridor connecting continents and carrying millions of passengers and enormous volumes of cargo every year. It would instantly become one of the most important pieces of infrastructure on Earth. Protecting it would require advanced monitoring systems, emergency response networks, cybersecurity defenses, maintenance teams, and international cooperation. A disruption inside the tunnel could affect transportation across multiple countries. Reliability would become absolutely critical. And then there is the simplest question of all. What if people do not use it? Supporters predict enormous demand. Critics remain skeptical. Air travel is already fast. Shipping is already efficient. Would enough passengers choose multi-day rail journeys? Would enough businesses shift freight operations to justify the investment? No one can answer with certainty, because the project has never existed before. The future demand is impossible to know, and yet, despite every challenge, despite every risk, despite every warning, the dream survives. Because humanity has always been drawn toward impossible frontiers. Towns, the highest mountains, that outer space. Every generation faces a choice: to remain within existing limits or to push beyond them. The Iron Silk Road stands at that crossroads today. It could become one of the greatest failures ever attempted, or one of the greatest successes in human history. And that uncertainty is what makes the story so fascinating. Because now we arrive at the final question. If humanity actually succeeds, if the tunnel is built, if the continents are connected, how will future generations remember this moment? The day humanity connected the continents. Imagine standing here 100 years from now. The year is 2155. A child looks out the window of a high-speed train racing beneath the Arctic Ocean. To them, the journey feels completely normal. They have never known a world where Asia and North America were separated. They have never known a world where crossing continents required airplanes or weeks at sea. For them, the Iron Silk Road is simply part of everyday life. Just another railway, just another tunnel, just another connection. But we know the truth. Because we lived before it existed, we know how impossible it once seemed. We know that people laughed at the idea. We know that experts debated it. We know that politicians argued over it. We know that engineers stared across the frozen Bering Strait and wondered whether humanity could ever overcome such a challenge. And perhaps that is why projects like this matter. Not because they are easy, not because they are profitable, not because they are convenient, but because they reveal something extraordinary about the human spirit. Throughout history, humanity has always looked beyond the horizon. When oceans blocked our path, we built ships. When mountains stood in our way, we carved tunnels. When continents were separated, we built bridges. When the sky seemed unreachable, we learned to fly. And when space itself appeared impossible, we walked on the moon. Every generation inherits barriers, and every generation decides whether those barriers are permanent or temporary. The Iron Silk Road represents more than a transportation project. It represents a question. A question every civilization eventually asks itself. How far are we willing to go to connect with one another? Because beneath the steel, concrete, technology, and economics lies a deeper truth. The project is not really about railways. It is about people. People trying to shorten distances. People trying to create opportunities. People trying to build a future larger than themselves. Maybe the tunnel will never be built. Maybe it will remain a dream discussed only in engineering conferences and history books. Or maybe, one day, trains really will travel beneath the frozen waters of the Bering Strait. Maybe future generations will look back at this moment as the beginning of something extraordinary, a turning point, a new chapter. A day when humanity decided that oceans would no longer divide the world. Because if history teaches us anything, it is this. The greatest achievements of civilization always begin the same way, as an impossible idea. And perhaps somewhere in the Arctic, beneath the ice and darkness of the Bering Strait, the next impossible idea is already waiting. Waiting for humanity to make it real, emotional ending line. For thousands of years, oceans separated humanity. Perhaps the future begins the day we finally connect them. If you enjoyed this journey into one of humanity's most ambitious dreams, don't forget to subscribe to Earth Discovery 360, because our world is full of mysteries, megaprojects, and incredible stories waiting to be discovered. Thanks for watching, and we'll see you in the next adventure.